So with this introduction to porosity, we'll next look at an example problem of how to calculate the porosity of a soil given the information by which we can first determine the bulk density. If we look at the top of our illustration here, we're first looking at bulk density. We would know the soil weight. This would be a dry weight, an oven dry weight basis, and let's say for the purpose of this example we have an oven dry weight of 4 grams. The volume that this amount of soil occupies is 2.6 cc's, cubic centimeters, which of course is equivalent to the milliliter as we discussed earlier. So with that information you would calculate bulk density and porosity. The bulk density would to determine this, we would simply take the weight of 4 grams divided by the volume of 2.6 cubic centimeters, and this would give us a value for bulk density on this particular example of 1.54 grams per cc. Since we're going to be taking this number bulk density and using it in another calculation, we would want to carry the bulk density value out to hundredths. So in other words, we would not round this to 1.5, we would leave it at 1.54 grams per cc. The formula for porosity that I described earlier is equal to 1 minus the ratio of bulk density to particle density times 100, because we want this porosity value expressed as a percentage, and that's why we multiply it by 100. So if this is the formula for porosity, and we've just calculated bulk density in this example problem to be 1.54 grams per cc, we simply take that value of 1.54, plug it into our formula. Where did the 2.65 come from? Remember when I discussed particle density, I indicated that we were going to use the constant of 2.65 grams per cc to represent particle density. So this number will not vary from one calculation to the next. It will be what we'll call a constant. So in this particular example, our porosity is equal to 1 minus the ratio of bulk density, 1.54, divided by particle density, 2.65, both of those in grams per cc, times 100. And we follow through on our calculation. 1 minus 0.58 times 100 equals 42%. So we're saying that the porosity of this particular soil would be 42%, given a bulk density value of 1.54 grams per cc, which is calculated from a given or known weight of soil occupying a known volume. If we look further at this porosity formula, what we're really saying is that if 1 represents 100% of soil volume, what would the ratio of bulk density to particle density represent? Well, that number, which in this case is 0.58 or 58%, represents the volume of solids in the soil. Because 1 representing 100% of soil volume minus 0.58 representing the decimal form of the percent of this soil occupied by solids will give us the 42%, which is the percent of this soil's volume occupied by pore space. So the ratio of bulk density to particle density is really expressing the volume of solids in this particular soil. One more time. 1 represents 100% of soil volume. Bulk density divided by particle density, that will always be a decimal number less than 1. That represents the decimal form of the percent of soil solids. And when we subtract soil solids from 100% of soil volume, we are going to end up with our percent of pore space, once we multiply this times 100 to convert the decimal to a percent. So this particular soil has a porosity of 42%. Now if we look at this value that we calculated for bulk density up here of 1.54 grams per cc, where did we say that that type of soil, soils which have a bulk density of 1.5 to 1.6 grams per cc, where do they normally fall in the textural class range? Well, hopefully you'll recall that these soils are going to be on the upper end of the loam textural class to the lower end of the sandy or coarser texture type soils. So we're really saying here that a soil with a bulk density of 1.54 and a porosity of 42% is a fairly normal number for a silt loam to a fine sandy loam type of soil. Now, if we had this same type of textural class of soil, if we compacted it, which is to say we increased the bulk density, then an increase in bulk density would cause what to happen to porosity? Well, if we increase the bulk density value, that means we're going to be taking a larger number away from 1, which means that will cause a decrease in porosity. So as the bulk density value for a soil goes up, which is an indication that we have compacted that soil or squeezed the airspace out, we would expect to see a corresponding decrease in the pore space or porosity, which is indeed true. The formula tells us that an increase in bulk density will cause a corresponding decrease in porosity. And what causes an increase in bulk density? Poor management practices and or things which will lead towards soil compaction. Working the soil too wet, reduction of organic matter content, running heavy tillage implements or farm machinery over the soil, all of these things can cause compaction to occur under field conditions.